In this video, we're going to factor a polynomial using the rational root theorem. So suppose this question asked you to factor a polynomial and it didn't give you one of the zeros. Because remember, that's what was happening in the last video, right? We were given a zero and then we were asked to find the factors of the polynomial. Well, what if it just gives you the polynomial itself and asks you to factor it? What do? Well, what you can do is you can use something called the rational root theorem. What the rational root theorem is, it gives you a list of values that are all possible roots of the polynomial. So it doesn't tell you the exact roots, just a list of possibilities. So here's how you use this theorem. First of all, you're going to make sure that your polynomial is in standard form. Once it's in standard form, you're going to look at the constant term and the coefficient of the leading term. So what you're going to do is you're going to set up a fraction. In this fraction, in the numerator, you're going to write all the factors of the constant term. In the denominator, you're going to write all the factors of the leading coefficient. So let's look at this example. Let's suppose we want to factor 2x cubed plus 9x squared plus x minus 12. So we list out all the factors of 12 in the numerator, and then we write all the factors of 2 in the denominator. Now what we're going to do is we're going to combine the numerator and denominator and form fractions. So the way I like to do this is I go through all the numerators and put them over one denominator, and then I go through all the numerators and put them over the second denominator. So here's what that looks like. So for example, let's start off by putting everything over 1. So that's going to give me plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. So notice that these are all over 1, so I can just write these as integers. I can just write these as plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So now let's take all of these numerators and put them over 2. So when we do that, we get plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, plus or minus 4 over 2, plus or minus 6 over 2, and plus or minus 12 over 2. So now let's reduce these fractions. Well, plus or minus 1 over 2 can't be reduced. Plus or minus 2 over 2 is just plus or minus 1. Well, notice that's already in our list, so we don't have to write it again. Then we have plus or minus 3 over 2. And then let's see, plus or minus 4 over 2 is going to be plus or minus 2, which is already in our list. Plus or minus 6 over 2 is plus or minus 3, which is already included. Plus or minus 12 over 2 is plus or minus 6, so we don't need to write that again. So this list right here tells me all the values that are possible roots to this polynomial. So you may be wondering, well, we're trying to factor a polynomial, so why are we talking about finding the roots? Well, if you remember, the factors of the polynomial are related to the roots. If r is a root of the polynomial, that means that x minus r is a factor. So if we know the roots of a polynomial, we can actually write the equation of the polynomial in factored form. So let's continue with this example. So here we have listed out all of our possible rational roots. So now we need to check this list, okay? So we need to check all of these values. And so we're going to test them and see whether they make f of x equal to 0. Well, based on the fundamental theorem of algebra, we know that since this is a cubic polynomial, we're looking for 3 roots. Okay, so out of this list of roots, we're actually only needing to find 3 values. So for example, since we have plus or minus 1, we can start off testing x equals negative 1. So like I've told you before, I prefer to use synthetic substitution to test these. So I put negative 1 here, right? And then I write out the coefficients of f of x. And when I do synthetic substitution, my remainder is negative 6. Okay, so remember the factor theorem tells us that if we have this negative 6 here, that means that negative 1 is not a root. Okay, if it was a root, then we should be getting 0 here. So now we've eliminated one possibility out of this list of roots, so we need to try the remaining 15 values. So, you know, when I say this, and this happens every year when I say this in class, when I say we need to try the remaining 15 values, everyone's like, oh no, that's a lot of synthetic substitution, right? So if you're sitting here thinking that, I want to let you know that there is a shortcut, okay? Since we have Desmos and we have access to this graphing calculator, we can use it to actually help us out. So what I would suggest doing is entering this into Desmos, okay? And like we've discussed before, remember that the x-intercepts tell you the roots of the polynomial. So yes, I know that you don't have to do any of these extra steps that I'm telling you. You can just type this into Desmos and it will tell you all the roots. However, I do want you to learn synthetic division and how we're going about doing this and finding these factors. So as a shortcut, I'm saying, well, instead of doing synthetic substitution 15 times, use Desmos and then use it to figure out one root, okay? So from these three, you can say, okay, well, maybe -4 or 1. I think it's a little bit better to pick one of the ones that's integers, just because whatever we pick, we're going to do synthetic substitution. And I prefer to use synthetic substitution with integers. Okay, so let's suppose that I pick the root of 1, okay? So what I would do is I would put 1 here, and then I'm going to do my synthetic substitution, right? Because that's going to show me that this is a root. So for example, so I bring down my 2, okay? 1 times 2 is 2. 9 plus 2 is 11. 11 times 1 is 11. 11 plus 1 is 12. 12 times 1 is 12, and -12 plus 12 is 0. Okay, so we expected that 0 because we do know that 1 is a root. So that means that x minus 1 is going to be one of the factors of the polynomial. Okay, remember what we can do after synthetic division is we can write this now depressed polynomial because the original one was a cubic. So when we do synthetic division, that's going to result in a quadratic, right? And the square term is going to have a 2 coefficient, and then we have 11x and then plus 12. Well, now, I mean, I know some of you may be wanting to just copy these values down from Desmos, but we actually know how to factor this, right? Because it's a trinomial, so we can actually use the factoring methods that we talked about previously. So for example, 2 is A, 11 is B, and 12 is C, right? So we're going to be looking for factors of A times C, which is going to be 2 times 12, which is equal to 24. So we need to find factors of 24 that are going to add up to 11. So let's list out the factors of 24. So we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So let's see, 24 is positive and 11 is positive, so we want all our factors to be positive. So let's go ahead and add these together. 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, 4 plus 6 is 10. So this is the correct combination. So now let's do our factoring by grouping. So we have 2x squared plus 3x plus 8x plus 12. So let's put the terms into two groups. And so that's going to give us this. And now we can factor out the GCF of each group. So from the first group, we can factor out an x. So we do 2x squared over x plus 3x over x. So that's going to give us x times 2x plus 3, and then plus over here we can factor a 4 out of both terms. So we have 8x over 4 plus 12 over 4. So that's going to give us plus 4 times 8 over 4, that's going to be 2, and then we have x plus 12 over 4, which is 3. So we factor out that common binomial of 2x plus 3, and then we have our outside terms, which are x plus 4. So now remember, when we write the factored form of the polynomial, we have to include all of the factors. So we have the f of x is going to equal 2x plus 3 times x plus 4 that we just found, but we also need to include that original binomial that we factored out, right? So that x minus 1 gets included in our final answer. So this is the fully factored form of f of x. So yeah, that's what happens when we put all the factors together. And notice that this does match the information given to us by Desmos and the rational root theorem, right? Because if we solve these factors, for example, x minus 1 tells us that we have a root of x equals 1. 2x plus 3, if we set it equal to 0 and solve, like we can subtract 3 from both sides, and we get 2x equals -3. And then divide both sides by 2, so that's how we get x equals -1.5, or -3 over 2. X plus 4 tells us that we have a root at x equals -4. And notice that these are the three values that Desmos told us. Also notice that these values are included in our list, right? We have +1, -3 halves, and -4. So, it's just that we use Desmos to help us out a little bit so we didn't have to do synthetic substitution so many times. So here are steps, right? Everything all together. So make sure that the polynomial f of x is in standard form, and then determine the possible rational roots using the factors of the constant and the leading coefficient. You can graph in Desmos to help you determine which value in the list is a rational root, and then write the factor based on that rational root. Perform synthetic division with r to determine the depressed polynomial, and then keep repeating until the depressed polynomial is a quadratic. Then factor the depressed polynomial to determine the other factors, and then write the factored form of f of x, and remember to include the x minus r. So let's look at this example. So let's factor 6x cubed minus 31x squared minus 31x plus 6. So I'm going to start off by trying to determine the possible roots. Okay, so I need to look at the factors of the leading coefficient and the constant term. So the possible roots are going to be plus or minus 1, right? I'm writing out the factors of 6, plus or minus 2, and plus or minus 3. And that's going to be over, well, the leading coefficient's also 6, so we have the same factors. So let's first write all of the numerator over 1. So we have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1. Okay, now let's go to the next denominator, the 2. So we have plus or minus 1 over 2, plus or minus 2 over 2, and plus or minus 3 over 2. Okay, and now we have the third denominator, which is 3, plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 3 over 3. Okay, let's reduce whatever we can. So we have plus or minus 1, plus or minus 2, plus or minus 3. Plus or minus a half, plus or minus 2 over 2 is going to be plus or minus 1. Plus or minus 3 over 2, plus or minus 1/3, plus or minus 2/3, plus or minus 3 over 3 is going to be plus or minus 1. Okay, so here are all our possible rational roots. So now we're going to graph in Desmos, and we can use that to help us kind of narrow down and figure out at least one root. So what I did is I went ahead and graphed in Desmos, and I found that x equals -1 is a root. So that means that we have a binomial factor of x plus 1. So let's go ahead and divide that out using synthetic division. So I'm going to put my -1 here, and then I have 6, -31, -31, and 6, right? Because those are all the coefficients of f of x. So I bring down 6. 6 times -1 is -6. -31 plus -6 is -37. -1 times -37 is 37. -31 plus 37 is 6. 6 times -1 is -6, and then we have 0. Okay, so we started off with a cubic polynomial, all right? So my depressed polynomial is going to have a highest degree term of x squared. So that's going to be a 6x squared minus 37x plus 6. So now what I need to do is I need to factor this. So I'm going to factor 6x squared minus 37x plus 6. Okay, so here a is not equal to 1. So I'm going to say that a times c is equal to 36. So now I need to find factors of 36 that are going to add to my b value, and in this case b is -37. So since 36 is positive and my b is negative, that means I need 2 negative factors. So I'm going to list out the factors of 36 and then make them all negative. So the factors are 1 and 36, and then we have 2 and 18, 3 and 12, and 4 and 9, and we have 6 and 6. Okay, so now let's go through and make all of these negative before we find the sums. So -1 plus -36 is -37, which is the correct pair. If you check all these other ones, you'll notice that they're actually not going to work. So let's go ahead now and do our factoring by grouping. So we have 6x squared minus 1x minus 36x plus 6. So let's put these now into two groups. So 6x squared minus 1x plus -36x plus 6. So let's factor now the first set. From the first set of terms, we can factor out an x. So we have 6x squared over x minus 1x over x. So that's going to be x times 6x squared over x is going to be 6x, minus 1x over x is going to be minus 1. From the second set, well, that leading term is negative, so I'm going to go ahead and factor out a negative, and both terms are divisible by 6, so I'm going to factor out a -6. So we have negative 36x over negative 6 plus 6 over negative 6. So that plus negative 6 I'm going to turn into a minus 6. Negative 36 divided by negative 6 is positive 6, and then we have x plus 6 over negative 6 is going to be minus 1. So we have a common binomial factor of 6x minus 1, and then we have the terms on the outside, which are x minus 6. So now when we finally write f of x in fully factored form, we're going to write these two binomials that we have here, and we go back and pick up this one that we found when we factored in Desmos, right? So we had x plus 1. That was also one of our factors. Okay, so that is the fully factored form of that original expression. Video and try doing this example on your own. So here what I did is I started off listing out the possible roots, and then you can see here when I formed the fractions and reduced my list, this is the list of values that I got. So once again, I went to Desmos and I narrowed down this list a little bit. I found that x equals 2 is a root, which means that x minus 2 is a factor. I then did synthetic division, so I did 2, and then I listed out all the coefficients of the original polynomial. Synthetic division gave me the depressed polynomial 2x squared minus 5x minus 3. So I can factor this by multiplying a times c, which gave me negative 6. So I need factors of negative 6 that add to negative 5. Since 6 is negative, I need a positive and a negative factor. Since 5 is negative, I'm going to make my bigger factor negative. 1 plus negative 6 gives me the correct combination. Then I use that to expand out that negative 5x term. I put my terms into two groups. From the first group, I factored out an x, so that gave me x times 2x plus 1. From the second group, I factored out a negative 3, so I have minus 3 times 2x plus 1. So I have these two factors from my last factoring step, right? 2x plus 1 times x minus 3. And then don't forget, I need to include this x minus 2 that I factored out originally. So remember, you can factor a polynomial by determining its rational roots. The rational root theorem will help you determine all possible roots, and then you can use Desmos or synthetic division to figure out the actual roots. Once you've found an actual root, you can divide using synthetic division and find the depressed polynomial. You can then factor the depressed polynomial to fully factor the polynomial function.